Hello and welcome to the Erlang Solutions monthly webinar. My name is Mladen Milicic and I'm the VP for the EMEA region here at Erlang Solutions. Today's webinar represents a continuation of a series of webinars we have been running across topics of interest in the world of Erlang and Elixir and dealing with solutions based on the beam. Specifically today, we will be talking about securing Erlang and Elixir applications through moving target defense. And we will be discussing how moving target defense can be implemented to make container environments highly resistant to attacks. As with any live event, please do excuse any technical issues that we may face today. But to start by telling you a bit about Erlang Solutions, we are a products and services orientated company entirely devoted to the Erlang and Elixir programming languages. We work with organizations and individuals using Erlang and Elixir. We help evolve the languages and we support people and businesses using them. We are headquartered in London with offices in Stockholm, Krakow, Budapest, San Francisco, and Buenos Aires. And we work on projects across industries and across the globe itself. We develop Erlang and Elixir-based products, and some of those you may have heard of, such as Mongoose IM, our open source messaging platform, and Wombat OAM, our monitoring and management technology for Erlang and Elixir systems. I'm really pleased to say our speaker today is Alex Gounares, the CEO of Polyverse. We are indeed deeply privileged to have Alex speaking at the webinar and telling us a bit about Polyverse's latest achievements. Please allow me to finish by saying you are very welcome to pose questions throughout the duration of the webinar by using the chat facility on the webinar's interface. Our speaker, Alex, will answer as many questions as time allows at the end of the webinar. But if any questions do go unanswered, you're welcome to raise them via email using my address, which will be displayed at the final, on the final slide of today's presentation. I would now like to hand over to Alex, who will be glad to start us off.
Thank you, Mladen. It's great to be here. Good morning and good afternoon to everybody, depending on where in the world you are. I'm delighted to be working again and hosted by Erlang Solutions. For those of you that don't know me, I'm a longtime Erlang programmer, having used Erlang actually for about better over a decade now at various organizations that I've been in. And so I'm quite a fan, and Erlang Solutions is absolutely one of the top partners you can work with if you're doing anything with Erlang or Elixir. So delighted to be working with you all again. To jump in a little bit about who I am, and if you don't know me, and who the Polyverse team are. For myself, prior to doing Polyverse, I was the CTO for AOL and the CTO for Microsoft Online. And I'm probably best well known for being the technical advisor to Bill Gates for many years. The founding team here, our CTO, Archie Score, used to run the site security and reliability team for Amazon.com. And our head of engineering, Chris Hanaoka, ran the infrastructure for Azure and was responsible for over 1 million servers. I bring this up because we have a team here that is very familiar and very empathetic to the challenges that many of you on the call face in running modern systems. There's a lot going on in the world today, and fundamentally there's a tension between traditional cybersecurity and the business needs, represented here by DevOps, but for anybody technical on the call, how many times has your CEO asked you to go slower, right? There's very, very few businesses in the world where they ask us to go slower. And from the engineering perspective, we collectively have evolved technologies like DevOps and continuous integration, and even technologies like Erlang that allow us to write code rapidly and deploy it without any downtime. So we can do sort of these in-place deploys and take advantage of a lot of the other great features of Erlang. And all those capabilities really drive towards speed and agility. When you look at traditional cybersecurity models, however, it's very much a contrasting mindset. traditional security says lock things down, have a lot of process, really keep things under heavy change control. Always be watching. You have to do patches all the time, and you've got to watch your systems 24/7 in case something might happen. And that sort of process heavy model just really flies in the face of the modern DevOps type approach. And so when we think about a modern cybersecurity solution, it needs to be one that really works well with the fast and agile manner in which software is being written today. All right, well, to jump into how we think about cybersecurity, I'll do a quick 2-minute refresher on cybersecurity and in particular how attacks work. For those of you that might be a fan of American Hollywood movies, there's sort of this myth of the 30-second attack. You have your hacker and they're in the movie and they write the virus super fast, and then in 30 seconds they can take over the alien mothership and blow it up. And in reality, cyber attacks don't work that way. Cyber attacks take advantage of static and homogeneous systems. An attacker will go in, they will reconnoiter, do reconnaissance around your system. They'll break in somewhere. And typically they break into an edge system. They'll break into the firewall, they'll break into an edge or caching server, they'll break into your middle tier. Sort of one of those first systems that is processing outbound data or inbound and outbound data. From that initial foothold, they'll put in what's called the advanced persistent threat, their backdoor, and then they do additional reconnaissance, looking around for the next systems to get into. And then they weave their way around and eventually get to the data or the system or what have you that they're trying to control or perform their malevolent act on. So these attacks tend to be very thorough. They're very time consuming, and they are multiple step. The average time to detection of an attack like this is over 230 days. So once somebody gets in, they typically have 2/3 of a year in which to play around and cause whatever damage they're going to do. So it's a very, very long time that attackers are able to work their way through your system. And the challenge is that traditional cyber defenses, frankly, don't work. Your firewalls, antivirus, things like that. There's a lot of great products on the market. By all means, use them. They're very effective at getting rid of the so-called script kiddies and the attacks that are just sort of well-known and automated, but they don't get rid of any sophisticated actor. And we've seen this recently with the Petya and WannaCry attacks. These are the dreaded zero-day attacks, where somebody's able to get in even against a fully patched and fully firewalled system. And the issue is just very, very simple, in that the way that a modern attack can get in and bypass a firewall or bypass an antivirus system is they literally use your system, your application, your Linux system, your whatever. They use that as the virus. And there's a technique, there's a wide variety of techniques, but there's one particular one known as return-oriented programming. There's variations of it called cop programming, jump programming, move programming, and so forth. But the whole idea is essentially you string together your virus using the assembly code and binary code that is already on the system. And so for those of you that have maybe never seen a real zero-day, that string of characters on the bottom, that is a zero-day virus. That particular string of characters will take over a Linux machine running Java. and give the attacker shell access as root. That's all it takes. Now this string can be sent in as part of an image. This could be sent in a URL. There's any number of ways for this attack to happen. And fundamentally, it's just using the code that already exists in the system. And so if you have a Java application powering your e-commerce system, what are you going to do? What's antivirus supposed to do? Delete Java? You can't. That's your system. It's supposed to be there. It's supposed to be permissioned. It's supposed to have all this capability. So when the attackers can corrupt your existing environment, it becomes very, very challenging for traditional defenses to defend against it, because all of that code is supposed to be there and it's supposed to be permissioned. Having been a long-time Erlang programmer myself, I imagine some of you on the webinar here are thinking, well, that's great for Java, that's great for C, but I do functional programming, so I'm okay. And if you're thinking that, you are 50% correct, I would say. Absolutely, functional programming is a brilliant way to go. It does eliminate large classes of errors that are common in C and C++ and other languages. However, the unfortunate reality is that until we get to a pure functional programming system from the chip all the way up, the reality is we all work and live in mixed environments, and those mixed environments have bugs. Erlang OTP in particular, the runtime has had some pretty severe bugs over the years. There was one just last year, for example, that was a heap overflow in regular expressions. And this allowed an attacker to take over a system if there was any regular expressions being used in parsing external input. And so these issues can be quite severe. And as an open source project, you have both the advantage of thousands of eyeballs making the Erlang system better and better. You also have the disadvantage of thousands of hacker eyeballs trying to find the various vulnerabilities. And as all of you who write code know, there's no such thing as perfect code. Every system has bugs. And it's not just Erlang runtime. You also have to worry about any other components that you may be using, such as Apache or Nginx or any other plugin modules to the Erlang system or what have you. So when you look at this from the attacker point of view, it's, the entire system is fair game. So now the question is, well, all right, that's a little worrisome. If anybody can get in and attack my system with 0 days and even functional programming is not going to help me, well, what do I do about it? The solution is actually pretty fundamental, and it's rooted in mathematical theory that actually goes back about 20 years. If you take a step back and pull back from firewalls and antivirus and all those things and think about it from a very fundamental perspective, the core issue in cybersecurity today is the static and homogeneous nature of the systems that we're using. If you're building an Erlang program or Elixir program, running on the Erlang virtual machine on, say, a Linux server, that's the same Linux that is available to every hacker and malevolent actor on the planet. Ditto with Windows, ditto with Java. There's only a handful of sort of systems out there that are popular. So if you're the attacker, who cares if it takes 100 people a year to craft an attack? Because if you can take over Linux, or you could take over Java, or you could take over Windows, there are a billion computers that you can take over. And so when you look at things like WannaCry or Fetcha, there are, I've actually had the chance to study the code behind those attacks. That was a very, very sophisticated code. But the code fundamentally relied, in the case of WannaCry, it fundamentally relied on understanding exactly how the Windows SMB system works. So if the attacks rely on the asymmetric economics of it's easier to hack than to prevent, what if we flipped it? What if we flipped the asymmetry, and instead of having static and homogeneous systems, what if we created dynamic and diverse systems? Such that if an attacker were to try to attack, they could, because everything still has bugs, but they have to do it and create unique attacks per individual machine and maybe per day. So if we can create a lot of dynamic diversity in a system, we can completely change the nature of attacks. And this is the whole idea, frankly, it was inspired by human biology. You ask the question, why have humans not been wiped out by choose your favorite virus? The bubonic plague, the Spanish flu, H1N1, Ebola. As devastating as these viruses and medical conditions are, it didn't take out the entire human race, because as humans, we're a very, very diverse species, and that diversity gives us strength and resiliency in the face of attacks. So let's create the same diversity in computer systems. So instead of having identical binaries across every system, what if every binary was unique? If we know that attackers are getting in and putting in their backdoors and Trojans and other malware and being able to reside and control your systems for over 230 days, what if we continuously reset systems? This whole concept of reverse uptime, keep them continuously clean and fresh. So even if somebody got in, the attack wouldn't be that big of a deal. Fundamentally, it's all about changing the asymmetry, or changing the economic model of attacks, where today it is a break once, run everywhere from the attacker's perspective. What if we change that to a break once, run once? Well, that's what we've done in Polyverse, and this is what Polyverse is all about, is taking that sort of mathematically proven idea of cyber resiliency through diversity and making it phenomenally easy to deploy and phenomenally easy to manage. And so what we've built is a series of tools that and so very much a Unix philosophy, and actually built in an Erlang manner, which I will talk about in a few minutes. But these tools can be used in an a la carte fashion to create this dynamism and create the diversity to protect yourself against zero-day attacks, protect yourself against advanced persistent threats and script kiddies and so forth. So let me walk through these tools very briefly, and then I'd be happy to go into any more depth for the folks that are curious at the end of the call. I'm still an engineer despite running the company, so I'm happy to go as deep as anybody may wish in the Q&A session. All right, binary scrambling. So if we call back a few slides, I showed you a 0-day using the ROP gadget technique. And so whether it's the ROP gadget technique or jump gadgets or other things, this is what WannaCry, Pecha, all these things are using as attacks these days. The solution to doing this is to create diversity in the code. So what we've done at Polyverse is we have a compiler-based binary scrambler. And what this does is create semantically identical binaries, but ones that literally every line of machine code is different. We change registers, we change order of evaluation of expressions, we change the layout of the binaries, such that if you're an attacker, you don't know what this binary is. You've never seen it before, and so it becomes difficult to impossible to actually engineer an attack against it without seeing it. From the end user perspective, from the customer perspective, it's completely transparent and invisible to you. For those of you that are familiar with RPM or APT or APK, the app stores, if you will, for Linux, what we've done is we've integrated our technology into the App Store. So you simply point yum or APT, point it to repo.polyverse.io, away from the default Red Hat repositories. And if you point to the Polyverse repository, every time you install, you get a unique version to that server. And then the next install you do, you get another unique version. Again, these are semantically equivalent binaries with identical performance. You can't tell the difference, and the rest of your development cycle is completely unchanged. So with one line of code, you can protect the totality of your open source stack. We do this for all 10,000 open source applications, all 10,000 major open source applications, including Erlang. And so if you want to have a unique Erlang that is resistant, highly resistant to things like the regular expression bug, you simply just install it from Polyverse instead of installing it from Red Hat or Ubuntu or what have you. So a very, very easy change to create diversity in your environment and provide a core level of resiliency to your system. So this is our binary scrambling tool. Again, one click install. Our second tool is this notion of rapid cycling. And for those of you that are using the OTP model in Erlang, this would be very, very familiar to you. And it's actually one of the places where we were, where the design was inspired from. So rapid cycling is this idea of continuously resetting your environment back to a known good state. If you go back to sort of the traditional model, both in how systems are run and how attackers are working, the traditional operations model is you measure uptime. I myself, when I was in Microsoft Online, we would go to Bill Gates and the board of Microsoft and literally brag about how long our environments had been up and running. Little did I know, all I was doing was bragging about how long the attackers had to reside in our systems and play around. So rather than trying to keep your systems running for a long, long, long time, keep the service running for a long time, but reset your environment rapidly. And with Polyverse, and if you're using a virtualization technology known as Docker, we can reset the environment as rapidly as every 5 seconds. Again, if you're familiar with OTP and how server processes can be reset and traffic rerouted, same idea, right? We have a software-defined networking piece that will take your Docker containers, spin them up in the background, send traffic to the background instances when it's time to swap, and then completely recycle and refresh the system. The net result of this is that if you have vulnerabilities like a logic flaw, a configuration error, any other type of, I'll just say any other type of cyber vulnerability, insider attack that is not based around these sort of WannaCry-like cyber attacks, you can still have a great degree of resiliency against them. I can tell you personally, having done quite a lot of white hat hacking and penetrating into systems, I've personally broken through every firewall and antivirus on the planet. It's pretty easy to do. But when you get in and you take control of a system, you're happiest day. But if you get kicked out after 5 seconds, it's incredibly frustrating. And in particular, that cycling eliminates the ability for somebody to get in and work their way through your system. Our final tool here is a traditional firewall. This is a web application firewall. It's based around Nginx and ModSec. Of course, we scramble and cycle that. Our firewall in particular is a lot easier to configure if you've used traditional firewalls. You typically configure them with regex and other proprietary languages. In the Polyverse firewall, you configure it just using plain old JavaScript. So it's very easy to create lockdown, whitelists, and so forth. We have advanced features in our firewall that are not available in competitive products, like completely arbitrary validation and detonation chambers and so forth. But fundamentally, what the firewall does, if you just use it in the one command line default configuration, what it does is it gets rid of the script kiddies. If you put a server up on the internet these days, you will be probed within 2 or 3 minutes. There was a great study done last year, great/fun, amusing, and horrifying at the same time. A gentleman put an internet-connected toaster on the internet and watched the traffic. And even with a toaster connected to the internet, within 2 minutes he was being attacked. So there's an awful lot of the so-called script kiddies and sort of port probing going on there, where just simply having an IP address that is live, attackers will find you and they will probe you for vulnerabilities. And so a good firewall is useful to basically eliminate that kind of noise. So combined between the scrambling, our cycling, and the firewall, we get rid of the script injection attacks, the script kiddies. We get rid of the nation-state level, crafted attacks that use these advanced techniques like rot programming. And we cover a wide range of configuration errors, insider attacks, and so forth. So again, all of these things are deployable with one line of code. And so it's meant to be very, very easy, low disruption to your existing environment and existing development cycle. For those of you that are doing Erlang and Elixir development, as I said, both myself and a number of the engineers, including our CTO on the team, we are all Erlang fans. And so not surprisingly, if you ever were to get a hold of the Polyverse code and look at it, even though we've written this in the Go language, it would look an awful lot like an Erlang program to you. And consequently, Erlang and Elixir are supported as first-class citizens for Polyverse. As I said, to get a unique scrambled Erlang, you simply install it from Polyverse. And that will give you a unique version that is resilient to any of the nation-state level or crafted viruses that are out there. In a similar spirit, if you're using OTP and so forth, that is an ideal candidate for the cycling approach that I mentioned to you. You can do this at the process level, but even better than that is to do the cycling at the entire application or entire Docker container instance level. And that way, if anybody were to take advantage of an error to put in a backdoor, you're completely eliminating it from the entire system. So again, we're big fans of Erlang and Elixir and have built our technology to work seamlessly with those style of applications. So with that, let me hop to a quick demo. And what I want to demo here is the effect of doing cycling on a normal system. And so I have a model here of just your normal web application, whether it's an e-commerce system, a web app, a big data analytics system. You have your edge servers, your middle tier, your microservices, and your storage tier. Again, this is meant to be a conceptual model, and I've sped it up greatly from the 230 days. These expanding red circles, which are hopefully animating, I actually don't know what order it's going to go in. It's a mathematical model here, a probabilistic system. What we're basically showing here is that if you have a static and homogeneous system, you let somebody get in and you give them time to look around, eventually they're going to find another system that is vulnerable. And then they're going to hop to that system. And then from that system, they're going to hop again. And eventually, they're going to take over the entire thing. It's not a question of if, it's a question of when. Because again, hopefully I've been able to convince you that all systems are vulnerable, all systems are hackable, because fundamentally, every non-trivial computing system has bugs, and those bugs can be exploited. And so rather than sitting there, to use an American phrase, like a sitting duck, waiting to get your system owned, if you adopt an approach of continuously resetting your system, even if you have a very severe vulnerability where somebody's able to get in and take over, an edge server, microservices, or whatever it is they're able to get into, the window in which they can cause damage is greatly reduced. I mean, it can be as small as 5 seconds. And so if you're continuously cleaning up, you don't have to detect every cyber attack. You don't have to, frankly, you don't have to monitor it all the time, because your system will be inherently self-healing, inherently resilient. At this point, I've said a number of times that applying moving target defense is very easy to do, and it's a very, very effective approach. But rather than just take a claim for it, let me walk through a real world example. This particular one was, unfortunately, a very confidential government customer. So I unfortunately can't describe exactly what they were doing, but suffice it to say, this is a very large scale big data analytics system. It's over 500,000 lines of code, a large number of developers running on a significant number of servers. And what fundamentally does is taking data feeds real time from around the world, ingesting them, running analytics in real time. And then they have, since as a customer, I'll say, wicked cool real-time visualization using HTML5 and WebSockets and so forth. So the users of the system are able to see the results of the analytics through some very frankly stunning visualizations. So this is a very complex system with real-time needs. Using a variety of both modern technologies like Docker, as well as a significant number of legacy pieces. We've been able to apply, or the customer applied, this moving target defense protection in the system using Polyverse with only 23 lines of code modified. I have the actual screenshots of their config file there. It's shrunk so that the text isn't visible to protect their confidentiality, but you can see the adds and deletes of what was needed to change their config file. And the changes were quite simple. It literally was installing and configuring Polyverse. And we used the features that I just talked you through, as well as a more advanced feature known as session isolation, which I'm happy to cover in Q&A or offline if anybody's interested. The net result, 23 lines of change to their configuration to protect 500,000 lines of code, all running real time across hundreds of servers. So this is a very practical, very easy thing to do to get state-of-the-art protection. And to this point about does the protection work? It does. We've had extensive validation by the US military, and we've done quite a number of commercial pen tests and other studies. A study that is currently in progress shows that literally 100%, don't quote me on this because the study is not complete, we still may find one or two exceptions to it, but so far it's looking like 100% of the remote code exploits in 2017 would be protected by this approach. One of the most interesting studies that we've done is, and actually there's a new ISACA paper that just came out today. I can send a link to folks that just was published late last night that has another test. But one of the most interesting ones that we did is we took some OWASP applications that from the Open Web Application Security Project. We took some incredibly vulnerable programs that were not patched. And these are ones that have known exploits. In fact, the OWASP project is kind of a training ground for both defenders and attackers. We took a completely unpatched system, applied Polyverse to it, and had a set of former nation-state hackers try to attack it. They had 6 weeks, all the source code, full knowledge of everything, along with a complete arsenal of attacks that should have worked. And despite having a completely unpatched system to defend, the Polyverse system completely protected it, and the attackers were unable to get through. So, I can't promise that that moving target defense as an approach can make systems invulnerable. We don't believe there's any such thing as an invulnerable system. But if you change the mentality of how you're approaching a problem, instead of being in a very reactive world of trying to watch your firewalls, watch your analytics systems, and stay up to date on patches, flip the model. Be dynamic, be diverse, make it so that you are phenomenally hard to attack. And if you can change the economics and put the economics in your favor, then we win. And cybersecurity, as a will become just part of the normal day of life, as opposed to the gigantic issue that it is today for Western civilization. Thank you very much for your attention. I'd be delighted to follow up with anybody that would like to learn more. And in the meantime, let me flip to Q&A.
First of all, Alex, let me say a big thank you on behalf of our audience for a most inspiring webinar. A truly fascinating topic you've covered, and thank you to our audience as well for sending a number of questions already. We're getting more questions that we can, I think, answer, so we'll start answering them as quickly as possible. Apologies to anyone in the audience who will not get their questions answered. I can assure you that we will answer your questions in writing after the webinar, but we will try and answer as many as we can right now. So I'll just sort of dive straight into them. The first question, and we'll ask these in the order in which they were received. We have Piotr asking, Alex, could you give us a real-life example of an attack on an Erlang application where binary scrambling prevented that particular attack? So just to repeat the question, yeah, Piotr is asking for a real-life example of an attack on an Erlang application which was prevented by binary scrambling.
So I don't have a, that's a tricky question to answer, and let me maybe give a slightly longer answer. So the short real life example is the one that I referred to earlier. Go back to that slide. The regular expression of vulnerability that allowed for an attack. And that's one that the binary scrambling does prevent. That's something that you can validate in the lab. I don't know of a publicly, to my knowledge, there hasn't been a public disclosure of that vulnerability affecting a customer. But for those of you that are sort of deep in the cybersecurity space, one of the sort of well-known challenges is that the vulnerabilities are very rarely disclosed, and the nature of the vulnerabilities and the attacks that happen are very rarely disclosed. Companies, quite frankly, are both embarrassed, and particularly in the United States, there's a significant degree of liability associated with it. And so having the sort of, I'll say, a publicly confirmed attack is rare to see. And so, the general, I'll say, conventional wisdom in the cybersecurity industry is that if there is a vulnerability that has been disclosed through a CVE, you can pretty much assume that it has been exploited by somebody, because these patches, these CVEs that I referenced before, they effectively become the blueprint. So if you're the blueprint for the attacker, so if you want an easy way to take over an Erlang system, all you do is go to the Erlang source code, look at the fix that was applied for that bug, and from that, you know exactly where and how to take advantage of the unfixed system, because you know exactly the nature of the vulnerability. So it becomes a very quick and easy way to engineer attacks, and that's sort of the tension, if you will, between patching, disclosing vulnerabilities and patches, is that you're just giving blueprints to the attackers. At the risk of giving slightly too long of an answer, fundamentally, when you take a moving target defense approach, there are attacks that happen that you don't necessarily even know about. I didn't cover it, but we've got a fairly extensive detection and sort of event system within Polyverse, so you can see the attacks. But fundamentally, it's impossible to know all the possible attacks, right? You just can't, because to know every attack, you would need to know every bug, and you just don't know every bug. So, there are attacks that happen that you don't know or understand the mechanism, and WannaCry is a really good example. That the underlying methodology for that, the source code and that vulnerability has existed for about 6 years or more. And so, there have been attackers that have been using that for coming up on 6 years or more, and it's only in recent months that it really came to light once it was disclosed more broadly. And that's very, very typical, where these attacks are completely unknown. And that's why we're big believers in the moving target defense approach, because it gives you resiliency even if you don't know what the attack is and you don't know that it's happening. You still are protected.
Thank you, Alex. I think that's a very comprehensive answer to what Piotr was asking. Now, to move straight on to the next question, and again, apologies to everyone whose question will not be answered in the available time. Felipe is asking, generally speaking, when should a person take care about the cybersecurity of a project? So would you do that at modeling time, or would you do that when you deploy? Because as Felipe is asking, to begin with, you do not exactly know which functions and features your application will actually have.
That's a great question. The short answer is all the above, and the practical answer is worry about it now. It's sort of never too late to think about security, and conversely, it's never too early to think about security. Even in the design phase, we don't know exactly the functionality you might have, or exactly what the code is going to look like. There are many things you can consider in the design of your application that can greatly impact the ease of which security is going to be an issue. Take something very simple like user authentication. Do you have users? Do they need to authenticate? Is that authentication going to be a single factor or multi-factor authentication? This isn't quite cybersecurity, but for those of you on the webinar in Europe, there are quite extensive new laws and regulations about data location and privacy. And so, the design of your cloud systems and where data is located, what access rights are there, what the sort of user, what your customer rights are with respect to how that data is handled, when, how much they can delete. in C. There's a lot of new regulations about it. So all those things, whether it's the fundamental code design, how you work with the users, or how you handle your data, all those are good to be thoughtful about even at the very beginning of your project.
Thank you for that, Alex, and we'll move straight on to the next question. We have Duncan asking, you mentioned 0 days in the operating systems, and he's basically saying he understands how the cycling minimizes the time available in the system, but the binary scrambling does not stop Windows 0 days. That's essentially what he's asking. So how do you sort of deal with that?
Great question. So for anything that is short answer, with our current technology that you can go to the polyverse.io and just download it, this works for anything where you have source code. So the Linux operating system, all of the programming stacks on top of that, like Erlang or Java or Ruby or Node.js, and then obviously your applications on top of those stacks. So if you have the source code, we can protect you top to bottom. On Windows, we're able to provide the cycling through cycling the virtual machines. And so that unfortunately is a little bit more of a configuration. The configuration for that typically takes a couple hours to less than a day. So we don't have that as a one-click download install, but if you have a Windows environment that you would like to protect that from 0 days, please contact me offline and we'll be able to help you out with that. It's just a touch more work because it's not quite as convenient as the Linux world.
Alex, thank you for that. And just to repeat, we will answer all the questions that are now coming in faster than we can respond to them in writing, so after the webinar. So do not worry, and please keep asking the questions you wish to ask. Now, moving straight on to a question from Rick. Now, Rick is asking, I think, quite an interesting question. If the containers are restarted every few seconds, then any transactions that are in progress will be lost and have to be rerun. So he's basically saying the average transaction time needs to be a fraction of your container cycling rate. So what would you say to that, Alex?
It's another great question. Fundamentally, this is what Polyverse handles. We actually support long-running transactions. So in the case study that I just gave you, the quote transactions there can run for many hours because it's an interactive, real-time sort of WebSocket session. And so we support this by virtue of software-defined networking. And essentially what happens is we do session management through the software-defined networking. So as the containers are cycling, let's say at that 5-second mark, new traffic, new transactions will be routed automatically to the previous standby. We'll create a standby system, have it ready to go. At 5 seconds, traffic is routed to that standby, new traffic. Existing traffic is allowed to flush. And then one of the things that you can easily do, and Mladen, with your indulgence, I'm going to skip ahead to one question that Mr. Goss asked about session isolation. So my apologies for everybody else in having Mr. Goss jump the line. But his question was, what does session isolation entail? Since it relates to the answer here. So fundamentally, to complete Rick's question, we handle transactions and we handle sessions. There's no loss to user experience, no loss to state. If your environment is one where you have extremely long-lived transactions, another technique you can do that's quite easy with us, again, it was all within this 23 lines of code for that particular customer, is you can isolate your sessions as well and literally put transactions into separate container instances. And so if I just walked you through the example of how we handle transactions, where they go through a running container. At 5 seconds, they flip over to the backup. Why not have 10 running containers and 10 backups? And that's something that's very easy to do with us, to basically create multiple instances of these and route traffic dynamically through your system and create isolation around session boundaries. So hopefully that answered both questions there.
Alex, thank you for that. So you've covered off both questions indeed, and that includes Michael's question. Now, just moving straight on to the next question, we have one of our audience members basically asking and concluding, the product seems to be based on proactive recovery. So kind of assuming you're going to have a security breach and then periodically recovering to a known good state. But you also mentioned that scrambling the code is an important part. So he's basically asking, what is more important? Which of these is more important, and why is obfuscating the application so important itself?
It's a great question. So the idea here of having sort of multiple different tools is the idea of there's no single silver bullet. I wish I could tell you that, oh, hey, just do scrambling and that will solve all problems. It won't. It solves a class of attacks known as these crafted malware, or more colloquially said, it solves the zero-day attacks. But there are other classes of attacks, like ones that take advantage of configuration errors and so forth, or compromised admin, the so-called insider attack and so forth. So each of these different tools is aimed at a different class of attack and kind of a different portion of your architecture. It's very, very easy, for example, to cycle your middle tier systems. Anything that is stateless or functional become ideal candidates for very rapid cycling. Your database tier is something where unless you have an incredibly flexible NoSQL-based data tier, cycling those systems is better done across minute or hour boundaries versus seconds. Just databases typically take, if you have a lot of data in them, they take a little bit more time to quiesce. So you were spot on, and with your permission, I'd love to use your phrase. I think you said it better than I did. This is all about going to proactive recovery. I think that's exactly the mentality, and then use the tool that makes the most practical sense for any given portion of your architecture. And we'd rather have you use just one tool and take a step forward than try to, as the saying goes, boil the ocean and solve everything all at once. Be practical, be fast, keep the DevOps philosophy, and make it easy and get incrementally better with every release.
Alex, thank you for that. I think the available time gives us an opportunity to answer perhaps 2 more questions. Okay. And move straight on to a question that has come in from Michael. So Michael is basically asking, if you keep a container alive for the duration of the session or transaction, as opposed to a static time such as 5 seconds, does that give an attacker an entry point for attack? Or is it possible to force a transaction container to restart after a certain amount of time?
Short answer is yes, it's possible. That is something that I typically don't talk about in an initial introduction to our technology, because when you do a restart of a transaction, it's something that you need to be a little bit careful and thoughtful about, so that that works if your transactions are restartable, for example.
Thank you, Alex. And I'll just ask one interesting thing that's sort of come in. Understanding that we've only just seen the webinar, and you've given us certain amounts of information, it's probably very new for everyone that has been participating in the webinar. But the question is, what if an attack can respond to you're dynamic, diversifying? And what if it itself can continually change and respond to your defensive activity?
That's a great question. It's one of these things where while we take great efforts to secure our own systems and protect our customers, even if the attacker knew everything that was going on, and like described in a lot of the validation we've done, we've given the attackers full knowledge of everything. There's a well-known security principle called Kirchhoff's principle. And what Kirchhoff's principle says is the best security works even if the attackers understand and know everything about it. And the example that's usually used with Kirchhoff's principle is public key encryption. I know the mathematics of public key encryption. Everybody knows it. I've got all the code for how it works, even as the attacker. It doesn't make, knowing all the code and knowing the mathematics doesn't make it easier to guess the prime number behind public key encryption. So the same principle applies with the binary scrambling and other techniques that we're doing here. You know, even if you know that you as the attacker, even if the attacker knows that you are have a scrambled system, they don't know which of the many billions of possibilities it is. They would have to try. Actually, on typical measures, there's more than a billion. There's about 8 quadrillion different permutations in a typical environment. So the attacker would have to guess which of 8 quadrillion possibilities exist. That's quite hard to do, even if you know that you've got to guess. It doesn't make the guessing any easier. And that's the fundamental thesis behind moving target defense. It's okay if the attackers know. It does not change the complexity at which it is to attack a dynamically diverse system. And that's where you get your strength from and your resiliency from.
Thank you for that, Alex. I think that's a very compelling answer. And finally, I'll indulge myself with a question, if you don't mind. And this is more on the side of, you know, I've visited the Polyverse.io web pages, and I would recommend everyone attending the webinar does the same. You know, we're convinced, we're sort of sold. How do we get a copy? Are you planning to serve individuals, or is this sort of more oriented towards organizations and businesses? If you do plan to serve individuals, is there a plan to sort of roll out a price point that would suit individuals? What are your sort of business intentions on that front?
A great question. Thank you, Mladen. We support customers of all sizes. Our full transparency and disclosure. You know, the bulk of our customers are Fortune 1000 and military organizations, as you might expect. Folks that are sort of in the thick of the cybersecurity war have been attracted to us. We've been in commercial production for over 2 years. This is very well proven technology. And we now have essentially self-service versions that scale up and scale down. Our cheapest, least expensive is $100 US. If you just go to polyverse.io, you can get a single server version for $100. And then obviously that scales up if you, anybody on the, if anybody on the call is working on a very large enterprise or government type system, we scale up to that level of complexity as well. And for everybody on this webinar, I'm very pleased to offer you a free trial. If you go to our website and use the code Polyverse Trial, that will give you a free version of our stuff to evaluate. And we'd love to have you do that. We'd be delighted to work with everybody. And quite bluntly, let's go win against all the bad guys here.
Alex, thank you so much. And I know that I would personally feel better if I had proactive defense on my machines. So I might just give that trial a go. So thank you for this. And I'm sure that everyone will join me in thanking you for a really inspiring talk. Many thanks to all of you who have joined us for the webinar as well. Please join us again for our next monthly webinar, and following today, we will send you a short survey just to make sure we capture your feedback of today's webinar. Now, also note that the recording of the webinar and the presentation that was shared today will become available for you to collect on Erlang Solutions' corporate website at www.erlang-solutions.com. Thank you all once again, and we very much look forward to seeing you at our next webinar.